I want you to think about your most recent data analysis project. Now imagine completing it 50 times faster with insights you never would have discovered manually. That's not just the promise of AI, it's the reality for businesses that understand how to approach it correctly. Today, I'm walking you through what MIT's George Westerman calls the leadership challenge of AI. Not the technology itself, but transforming how your business operates. By the end of this podcast, you'll understand the three-legged stool framework that will completely change how you evaluate AI opportunities in your organization. The business frustration reality. What if the most time-consuming tasks in your organization could be eliminated almost entirely? Consider the reality many businesses face today. Your financial analysis team spends 40 hours each month compiling quarterly reports. These analysts manually extract data from various systems, clean it, standardize it, and finally create visualizations for leadership meetings. Despite this significant time investment, these reports often contain only surface-level insights, delivered too late to influence critical decisions. This scenario plays out across industries every day. Marketing teams spend countless hours analyzing campaign performance data that could be processed and evaluated in minutes with the right AI systems. Supply chain managers manually review inventory levels and make forecasting decisions based on limited historical patterns they can personally recognize. Customer service departments sift through thousands of support tickets, trying to identify emerging issues that automated systems could flag instantly. The cost of this manual approach extends far beyond the obvious time expenditure. When humans manually process large data sets, they inevitably miss valuable patterns. A manufacturing company I worked with discovered this painfully. For years, their quality control team manually reviewed production data looking for defect patterns. When they finally implemented an AI-powered analysis system, it immediately identified subtle correlations between specific suppliers, temperature conditions, and defect rates, connections that had remained hidden for years despite dedicated analysis. This insight alone saved them over $2 million annually by reducing defects by 23%. This competitive disadvantage compounds over time. While your team spends weeks analyzing what happened last quarter, your competitors with effective AI implementation are receiving daily or even hourly insights that allow them to adapt quickly to market changes. The gap between companies that effectively leverage AI and those that don't continues to widen, creating what Mokrian calls the digital divide in competitive advantage. What makes this situation particularly frustrating is how universal it is. I've observed the same pattern across retail, healthcare, financial services, manufacturing, and professional services. Organizations of all sizes suffer from this inefficiency. From startups, where a single analyst struggles to keep up with growing data demands, to Fortune 500 companies, where entire departments remain stuck in manual processing cycles despite significant technology investments. The hidden costs extend beyond missed insights and competitive disadvantages. Employee burnout represents a significant hidden cost of manual data processing. Skilled analysts and subject matter experts grow frustrated when they spend 80% of their time on data preparation tasks rather than applying their expertise to generate valuable insights. This leads to higher turnover among precisely the employees you most want to retain, those with both domain knowledge and analytical skills. Strategic blindness represents another substantial cost. When leadership teams receive analyses based only on the most obvious metrics that are easiest to compile manually, they develop blind spots to emerging opportunities and threats. A retail client discovered this when they finally automated their customer behavior analysis. The AI system quickly identified a growing segment of high-value customers with unique purchasing patterns that didn't fit their existing customer personas. This segment had existed for over a year but remained invisible because their manual analysis couldn't process customer journey data at sufficient granularity. The most concerning aspect of this frustration is that many organizations have attempted to implement AI solutions only to experience disappointing results. According to recent studies, between 70–85% of AI projects fail to deliver their expected value. Why such a high failure rate? The fundamental problem is that businesses lack a coherent framework for AI implementation. Most organizations approach AI primarily as a technology challenge rather than a business transformation opportunity. They focus on securing the latest algorithms or platforms without first establishing the foundation needed for success. They jump directly to sophisticated machine learning solutions when their data infrastructure remains fragmented and unorganized. Or they implement AI solutions for problems that could be solved more reliably with simpler approaches. This disconnection between technology implementation and business strategy explains why so many organizations experience an initial burst of enthusiasm for AI, followed by disappointment and skepticism. Without a structured framework to guide implementation decisions, businesses often invest in solutions that aren't aligned with their most pressing business challenges or that lack the necessary foundation for success. What if there was a clear framework that could help you avoid these pitfalls? A systematic approach that would allow you to identify where AI can create genuine business value in your organization, assess your readiness for implementation, and build the necessary foundations for success. This is where Pedram Mokrian's concept of data-driven alpha becomes crucial. In finance, alpha represents the excess return of an investment relative to the benchmark index, essentially the value you create above what's normally expected. In the business AI context, alpha represents the competitive advantage you generate through superior information processing and decision-making. The key insight from Mokrian is that this alpha doesn't come from having the most advanced algorithms. Rather, it emerges from having the right data strategy, choosing appropriate analytical approaches for specific business problems, and implementing these solutions on suitable technical platforms, all in service of clearly defined business objectives. Organizations that generate significant alpha through AI focus first on identifying high-value business problems where enhanced information processing can create substantial value. They then assess whether their current data assets can support effective analysis of these problems. Only after addressing these foundational questions do they select appropriate analytical approaches and technical platforms. This framework helps organizations avoid the common trap of starting with a specific AI technology and searching for problems it might solve. Instead, it reverses the sequence. Start with the business problem, assess data readiness, then select appropriate technologies. This approach dramatically increases the likelihood of generating meaningful business value from AI investments. When implemented correctly, this framework transforms how organizations approach AI. Rather than viewing AI as a mysterious black box that somehow creates value through algorithmic magic, they understand it as a systematic approach to extracting insights from data and embedding those insights into business processes. This clarity allows organizations to make more strategic decisions about where and how to apply AI capabilities. The companies that have successfully implemented this framework report not only specific operational improvements, but also a broader transformation in how they approach business challenges. They develop what might be called AI thinking, a more systematic approach to information processing and decision-making that permeates the organization. But before we can generate this alpha, we need to understand what actually makes AI work in business contexts. Many of the fundamental misconceptions about AI's capabilities and limitations continue to hinder effective implementation. Let's clarify what AI actually is, and importantly, what it isn't, to establish a realistic foundation for business applications. Understanding AI's true business value. Why do most executives misunderstand what AI actually is? According to Pedram Mokrian, the fundamental issue stems from a definitional problem. Mokrian defines AI simply as a branch of computer science that deals with intelligent behavior in computers. This straightforward definition contrasts sharply with how many business leaders conceptualize AI as a magical solution that can independently solve complex business problems with minimal human guidance. This misunderstanding matters tremendously because it creates a dangerous gap between expectations and reality. When executives believe AI possesses capabilities beyond what current technology can deliver, they make investment decisions based on false premises. They allocate resources toward projects doomed to fall short of anticipated outcomes, not because the technology failed, but because their expectations were unrealistic from the beginning. The misconception about AI's capabilities pervades boardrooms and executive meetings. Many business leaders envision AI as portrayed in science fiction, systems with human-like reasoning, judgment, and adaptability across unlimited contexts. They imagine deploying systems that can independently recognize business problems, determine optimal solutions, and implement those solutions with minimal oversight. This vision stands in stark contrast to the reality of what AI actually delivers today. The critical distinction that often goes unrecognized is between narrow AI and super AI. Narrow AI, which represents all commercially available AI solutions today, excels at specific well-defined tasks within clear parameters. Take a Roomba vacuum cleaner. It performs one specific function, cleaning floors, within constrained parameters, a home environment, using sensors and algorithms. It does this task exceptionally well but cannot adapt to clean windows or organize your closet. This represents narrow AI, impressive within its designed function but limited to that specific domain. Super AI, by contrast, represents a hypothetical future technology capable of general intelligence, comparable to or exceeding human abilities across multiple domains. This theoretical concept can understand context, transfer learning between unrelated fields, exercise judgment, and adapt to novel situations. Despite frequent mentions in media and some corporate marketing, super AI remains entirely theoretical, not a current reality for any business implementation. This distinction matters tremendously for business applications. When executives confuse these categories, they often expect narrow AI solutions to demonstrate capabilities only possible with super AI. They anticipate systems that can understand nuanced business contexts, exercise judgment in ambiguous situations, and adapt seamlessly to changing business conditions, capabilities that exceed current technological possibilities. Marketing hype significantly contributes to this confusion. Vendors often describe their solutions using language that suggests greater capabilities than the technology actually delivers. Terms like intelligent, smart, and cognitive appear in marketing materials without precise definitions, allowing business leaders to project their own expectations onto these terms. The resulting expectations gap sets projects up for perceived failure even when the technology performs exactly as designed. Industry media further amplifies misconceptions by highlighting spectacular AI achievements without adequately explaining their limitations. For example, when AI systems defeat world champions in chess or Go, these victories receive extensive coverage. What receives less attention are the limitations. These systems excel exclusively at these specific games and cannot transfer their learning to other domains. This selective coverage creates an impression of AI capabilities that extends far beyond actual technological reality. Mokrian highlights how this misunderstanding connects directly to the Dunning-Kruger effect in AI adoption. This psychological effect describes a cognitive bias, where people with limited knowledge in a domain overestimate their expertise. In the context of AI implementation, Mokrian presents this using a 2x2 matrix that contrasts an organization's understanding of AI with their confidence in implementing it. Many business leaders begin at the peak of what Mokrian calls Mount Stupid, a point of high confidence paired with minimal understanding. At this stage, executives have absorbed enough marketing materials and industry articles to feel knowledgeable about AI capabilities without understanding the technical limitations or implementation challenges. This dangerous combination of high confidence and limited knowledge leads organizations to initiate ambitious AI projects with unrealistic expectations. As these projects progress, organizations inevitably encounter the reality gap between AI marketing promises and actual implementation challenges. Confidence plummets as technical difficulties emerge, data quality issues surface, and integration challenges multiply. Mokrian describes this transition as entering a danger zone, where disillusionment can lead organizations to abandon AI initiatives entirely, missing valuable opportunities for more realistic applications. This pattern explains why so many AI projects fail to deliver expected value despite using perfectly functional technology. The technology itself works as designed, but it cannot fulfill the unrealistic expectations established during the initial high-confidence phase. The root cause isn't technical failure, but expectation misalignment stemming from fundamental misconceptions about AI capabilities. For business leaders, moving beyond this pattern requires transitioning from theoretical knowledge about AI possibilities to practical understanding of current capabilities and limitations. This shift involves recognizing that valuable AI implementation depends more on clearly defining business problems than on advanced algorithms. It means understanding that data quality and quantity typically determine success more than algorithmic sophistication. Most importantly, it requires accepting that current AI excels at narrow, specific tasks rather than demonstrating general intelligence. Organizations that successfully implement AI understand what George Westerman emphasizes, that AI, while powerful, is not intelligent, but can act very intelligently. AI executes formulas based on programming and learned data, but lacks broader context, common sense, and the nuanced understanding that characterizes human intelligence. This realistic understanding sets appropriate expectations for what AI projects can achieve. The data from implementation experience is clear. Organizations that maintain realistic expectations about AI capabilities consistently report higher satisfaction with AI investments than those pursuing capabilities beyond current technological possibilities. Projects focused on specific, well-defined problems with clear success metrics deliver value more consistently than ambitious projects promising general intelligence or human-like adaptability. This explains why most AI projects fail despite promising technology. When executives expect capabilities that exceed what current technology can deliver, even perfect technical implementation will disappoint. The solution isn't abandoning AI initiatives, but aligning expectations with technological reality. This means focusing on specific business problems where current AI capabilities can deliver meaningful value rather than pursuing capabilities that remain theoretical. Understanding these distinctions transforms how organizations approach AI implementation. Rather than pursuing the most advanced algorithms or platforms, successful organizations focus first on clearly defining business problems where pattern recognition at scale creates value. They assess their data readiness before committing to specific technologies. They implement solutions focused on narrow, specific objectives rather than general capabilities. This realistic understanding of AI capabilities doesn't diminish its potential value. Current AI technologies can transform business processes through pattern recognition, prediction, classification, and optimization at scales impossible for human analysts. These capabilities create substantial value when properly applied to appropriate business problems. The key is matching current capabilities to suitable problems rather than expecting capabilities that don't yet exist. To avoid these pitfalls, business leaders need a framework for evaluating where and how AI can realistically create value in their organizations. This framework must bridge the gap between technological capabilities and business objectives, providing clear criteria for determining which problems are suitable for current AI solutions and which are better addressed through other approaches. Let's examine a practical framework that helps leaders make these critical distinctions. The three-legged stool framework revealed. What if there was a simple mental model that could transform your approach to AI implementation? Something that cuts through the complexity and provides a clear framework for evaluating AI opportunities. This is exactly what Pedram Mokrian offers with his three-legged stool framework, a straightforward but powerful model that has transformed how many business leaders approach AI. This framework serves as the foundation for successful AI implementation by providing a structured way to think about the core components needed. The beauty of this model lies in its simplicity. Rather than overwhelming you with technical details, it focuses on the essential elements that determine success or failure in AI projects. This makes it accessible even for leaders without technical backgrounds, while still capturing the critical factors that technical teams need to consider. The three-legged stool metaphor is especially apt because, like an actual stool, if any leg is weak or missing, the entire structure becomes unstable. Many AI initiatives collapse because organizations fail to recognize this interdependence, focusing too heavily on one component while neglecting others. Here's where most businesses go wrong from the beginning. They focus on the wrong leg of the stool first. Typically, organizations become captivated by sophisticated algorithms or the latest AI platforms. They invest in cutting-edge technology without first ensuring they have the necessary foundation to support it. This is equivalent to purchasing expensive ornate legs for a stool without first designing the seat, a fundamental misalignment of priorities that leads to expensive failures. The three legs of this framework represent the essential technical components of any AI system: data, algorithms, and platforms. Each serves a distinct purpose, and all three must work together effectively to create value. The first leg, data, represents the information assets that fuel AI systems. This includes both historical and real-time data from internal and external sources. The quality, quantity, and accessibility of this data largely determine what's possible with AI. Without sufficient high-quality data, even the most sophisticated algorithms will produce poor results. The garbage in, garbage out principle applies strongly in AI implementation. The second leg, algorithms, represents the mathematical models and techniques that process this data to generate insights or automate decisions. These range from simple statistical models to complex deep learning neural networks. Different business problems require different algorithmic approaches, and selecting the right one depends on both the nature of the problem and the characteristics of the available data. The third leg, platforms, refers to the technical infrastructure that enables data storage, algorithm deployment, and integration with business processes. This includes cloud computing resources, data warehousing solutions, and the systems that deliver AI outputs to end users. The platform must support both the initial implementation and ongoing operation of AI systems while integrating with existing business technologies. While these three legs are essential, they're not where you should start. Mokrian emphasizes that the seat of the stool, what holds everything together, represents the value proposition, the specific business problem you're trying to solve. This is where every AI initiative should begin. The seed answers fundamental questions. What business problem are we solving? Why does this problem matter? How will solving it create value? Without clear answers to these questions, the technical components lack purpose and direction. This problem-first approach mirrors core principles of entrepreneurship and innovation. Just as successful startups begin by identifying market needs rather than building technology in search of a problem, successful AI implementations start with well-defined business challenges. Mokrian stresses that identifying the key market or customer motivations and the specific problems that need solving is essential before considering technical approaches. Defining the business problem creates focus for the entire AI initiative. It establishes clear success criteria, helps prioritize technical decisions, and ensures that the project remains aligned with business objectives. Without this clarity, AI projects often drift toward technical exploration without delivering tangible business value. The framework fundamentally shifts focus from technology to business outcomes rather than beginning with questions about which algorithms to use or which platforms to adopt. It starts with questions about which business problems matter most and how improved information processing could address them. This reorientation helps prevent the common mistake of viewing AI as a solution looking for a problem, instead positioning it as a set of tools that can be applied to well-defined business challenges. This approach also helps evaluate whether AI is even the right solution for a given problem. Not every business challenge requires AI. And applying advanced machine learning to problems that could be solved with simpler approaches often adds unnecessary complexity and cost. The framework provides clear criteria for determining when AI is appropriate and when alternative approaches might deliver better results. By starting with the business problem, organizations can more effectively evaluate potential AI projects based on expected business impact rather than technical sophistication. This prevents the common situation where organizations implement technically impressive solutions that fail to deliver meaningful business value. It also helps prioritize projects based on potential return on investment rather than technical interest or following industry trends. The three-legged stool framework also emphasizes the interconnection between components. The nature of the business problem influences what data is needed, which in turn determines what algorithms are appropriate, which then affects platform requirements. These components must be aligned and balanced. Overinvesting in sophisticated algorithms while underinvesting in data quality typically leads to disappointing results. Organizations that have applied this framework consistently report more successful AI implementations. They avoid many common pitfalls, such as implementing AI solutions for poorly defined problems or selecting algorithms incompatible with available data. The framework provides guardrails that keep projects focused on business value rather than technical exploration. Perhaps most importantly, the framework helps establish appropriate expectations for AI projects. By starting with the business problem and systematically evaluating the readiness of each component, organizations develop more realistic timelines and resource requirements. This prevents the disillusionment that often follows overly ambitious AI initiatives built on unrealistic expectations. Understanding the three-legged stool framework transforms AI strategy by providing clear evaluation criteria for potential projects, rather than pursuing AI because competitors are doing so or because it seems innovative. Organizations can systematically evaluate opportunities based on problem importance, data readiness, algorithmic feasibility, and platform requirements. This structured approach leads to more focused investments with higher success rates. The framework also provides a common language for business and technical teams to discuss AI initiatives. Business leaders can articulate the problems they need solved, while technical teams can assess feasibility and requirements across the three legs. This shared understanding improves communication and alignment throughout the project lifecycle. As we consider the three legs of the stool, one consistently emerges as most critical to success. While all three legs are necessary, data quality and availability represent the foundation upon which everything else depends. Without sufficient high-quality data, even the most sophisticated algorithms and platforms cannot deliver valuable results. This explains why studies consistently show that data preparation consumes the majority of time in AI projects. The quality of the data directly determines what's possible. This brings us to a critical insight. Before investing in advanced algorithms or platforms, organizations must first ensure they have the data assets needed to support their AI ambitions. Let's examine why data strategy has become the essential first step in successful AI implementation and how organizations can build the data foundation needed for AI success. Data strategy, the foundation of AI success. What makes data the secret sauce that determines whether your AI project succeeds or fails? Simply put, without high-quality, relevant data, even the most sophisticated AI algorithms will produce disappointing results. In the three-legged stool framework we just explored, data forms the first and most critical leg, the foundation upon which everything else depends. Think about data as the raw material that AI systems transform into insights, predictions, and automated decisions. The quality, quantity, and relevance of this raw material directly determine what's possible with AI. Just as a master chef can't create an exceptional meal from poor ingredients, even the most sophisticated AI systems can't generate valuable insights from inadequate data. Here's where a fundamental tension emerges in most organizations. The way most businesses approach data collection and management is fundamentally misaligned with what AI systems actually need to function effectively. Most organizations collect data primarily for operational and reporting purposes, tracking transactions, monitoring performance, and meeting compliance requirements. This approach typically focuses on storing the minimum information needed for these functions, often in separate systems that don't communicate well with each other. AI systems, by contrast, thrive on rich interconnected data that captures the nuances of business operations and customer interactions. They require historical depth to identify patterns over time and breadth across business functions to make connections between previously separate domains. This misalignment between traditional data collection practices and AI requirements explains why many organizations struggle to implement AI successfully despite significant investments. To understand this challenge more clearly, we need to recognize the fundamental difference between structured and unstructured data. Structured data refers to information organized in a predefined format, typically stored in databases or spreadsheets. This includes transaction records, customer profiles, inventory levels, and other information that fits neatly into rows and columns. Most organizations have reasonably mature processes for collecting and managing structured data, though quality and integration issues often persist. Unstructured data, by contrast, lacks a predefined format and includes text documents, emails, social media posts, images, audio recordings, and videos. This type of data makes up approximately 80 to 90% of all enterprise data and contains valuable insights about customer sentiment, product performance, and market trends. Yet most organizations lack systematic approaches for capturing, organizing, and analyzing this unstructured information, creating a significant blind spot for AI implementation. The type of data available directly impacts algorithm selection and project feasibility. For structured data analysis, statistical techniques and machine learning algorithms like regression, classification, and clustering often prove effective. These approaches work well for predicting customer churn, optimizing pricing, and forecasting demand based on historical patterns in structured data. When implemented with high-quality structured data, these relatively straightforward algorithms can deliver substantial business value. Unstructured data, however, requires different approaches. Natural language processing algorithms help analyze text data, computer vision techniques extract insights from images and video, and speech recognition systems convert audio to analyzable text. These more complex approaches typically require larger data volumes and more sophisticated algorithms, increasing both the potential value and implementation complexity. Organizations must understand these distinctions to select appropriate technical approaches for their specific data assets. One healthcare organization learned this lesson through experience. They initially attempted to implement an AI solution for predicting patient readmissions, using only the structured data in their electronic health records, basic demographics, diagnoses, and procedure codes. The resulting model performed poorly, failing to identify many high-risk patients. When they expanded their data foundation to include unstructured clinical notes, which contained crucial information about social factors, compliance with treatment plans, and subtle clinical indicators, their prediction accuracy improved dramatically. The algorithm hadn't changed, only the data feeding it. This example highlights a pattern seen across industries. Successful AI implementations typically begin with data infrastructure transformation rather than algorithm selection. Organizations that achieve the greatest value from AI invest first in creating a solid data foundation, consolidating disparate data sources, improving data quality, and establishing governance processes that maintain data integrity over time. A retail company provides another instructive example. Before implementing any AI solutions, they spent 18 months creating a unified customer data platform that integrated transaction history, website interactions, mobile app usage, loyalty program participation, and service interactions. This consolidated view provided the foundation for multiple AI applications, from personalized recommendations to inventory optimization. Had they attempted to implement these applications without first addressing their fragmented data infrastructure, each project would have required duplicate data preparation efforts, and the results would have been based on incomplete information. What makes data strategy particularly challenging is that many data quality issues remain invisible until AI implementation begins. Organizations often believe their data is adequate because it supports basic reporting and operational functions. Only when they attempt to use this data for AI do the limitations become apparent. Inconsistent formatting, missing values, duplicate records, and outdated information that human analysts might intuitively compensate for, but that confuse algorithmic systems. A manufacturing company discovered this when implementing a predictive maintenance solution. Their maintenance records, which appeared adequate for regulatory compliance and basic reporting, contained numerous inconsistencies in how technicians recorded equipment conditions and repair activities. These inconsistencies, which human readers could interpret based on context, created significant noise in the data that prevented the AI system from identifying reliable patterns. Before they could implement their predictive maintenance solution, they needed to standardize their data collection processes and clean historical records, a process that took longer than the actual AI implementation. This experience raises an important question. How can you evaluate your organization's data readiness before investing in AI projects? Several key indicators help assess your data foundation. First, examine data accessibility. Can relevant data be accessed and combined from different systems within reasonable timeframes? If accessing and integrating data requires complex manual processes, your organization likely needs data infrastructure improvements before AI implementations. Second, assess data completeness. Does your data capture the key variables that influence the business outcomes you want to predict or optimize? Missing important factors will limit any AI system's effectiveness, regardless of algorithmic sophistication. Third, evaluate data history. Do you have sufficient historical data to identify meaningful patterns? While requirements vary by application, many predictive models need several years of historical data to capture seasonal patterns and long-term trends. Fourth, consider data quality. Is your data accurate, consistent, and timely? Quality issues magnify in AI applications as algorithms can't distinguish between meaningful patterns and artifacts created by data inconsistencies. Finally, examine your data governance. Do you have processes to ensure ongoing data quality and compliance with relevant regulations? Without governance, initial data quality improvements will deteriorate over time. This assessment often reveals that data strategy improvements yield greater returns than investments in advanced algorithms. Organizations frequently discover that addressing fundamental data challenges enables even relatively simple algorithms to deliver substantial value. A retail bank found that after consolidating customer data across previously separate systems, a basic recommendation algorithm outperformed a sophisticated system operating on fragmented data. The simpler algorithm with better data consistently generated higher customer acceptance rates than the complex algorithm with limited data access. This explains why data strategy is more important than the algorithms you choose. Quality data enables even simple algorithms to deliver value, while poor data will undermine even the most sophisticated technical approaches. The organizations that generate the greatest value from AI typically focus 70–80% of their initial effort on data preparation and only 20–30% on algorithm selection and implementation. With a clear understanding of data as the foundation for AI success, we now need to address a more fundamental question. Does your business problem actually require AI at all? Not every business challenge benefits from advanced machine learning, and distinguishing between problems that truly need AI and those better addressed through simpler approaches is essential for effective resource allocation. The AI necessity test. How can you tell if your business problem truly requires AI or if you're overcomplicating the solution? This question represents a critical evaluation step that too few organizations consider before launching AI initiatives. The AI necessity test serves as a practical framework for determining whether a specific business challenge actually requires artificial intelligence or could be solved more effectively with simpler approaches. Many business leaders feel pressure to implement AI solutions regardless of whether the problem at hand truly requires these advanced capabilities. This pressure comes from various sources: competitive positioning, market expectations, the desire to appear innovative, or genuine enthusiasm for new technology. The result is that organizations frequently deploy complex AI solutions for problems where simpler, more reliable technologies would deliver better results at lower cost. This over-application of AI creates several problems. First, it diverts resources from areas where AI could create genuine competitive advantage. Second, it introduces unnecessary complexity and potential points of failure into business processes. Third, it often delivers disappointing results that create skepticism about AI's value throughout the organization. As Dave Abar emphasizes, many organizations would benefit from prioritizing deterministic workflows over complex agent patterns, especially in their initial AI implementations. Consider a financial services company that implemented a sophisticated machine learning system to categorize customer service emails. After 6 months of development and implementation, they discovered that simple rule-based categorization achieved 95% accuracy, nearly identical to their AI solution, but with significantly less complexity and maintenance requirements. The AI system became a solution in search of a problem rather than a targeted response to a genuine business need. To avoid this trap, organizations should apply the AI necessity test before investing in AI solutions. This test involves 4 key questions that help determine whether AI represents the most appropriate approach for a specific business challenge. The first question examines whether the problem involves pattern recognition in complex data. AI systems excel at identifying patterns that humans struggle to detect: subtle correlations between numerous variables, nonlinear relationships that change over time, or patterns hidden in unstructured data like text, images, or audio. If your problem doesn't involve this type of pattern recognition, simpler analytical approaches often deliver better results. A healthcare organization applied this question when considering solutions for appointment scheduling optimization. They initially planned to implement a machine learning system, but recognized that the problem didn't involve complex pattern recognition. The key variables affecting appointment availability were known and relatively straightforward. They instead implemented a rules-based optimization system that delivered excellent results without the complexity of an AI solution. The second question evaluates whether the volume and velocity of data exceeds human processing capability. AI systems prove most valuable when they can process quantities of information far beyond what human analysts could reasonably review. If your problem involves analyzing thousands of transactions per second, monitoring millions of customer interactions, or processing continuous data streams from operational equipment, AI offers capabilities that simpler approaches cannot match. A manufacturing company applied this question to their equipment monitoring strategy. With sensors generating terabytes of data each day across hundreds of machines, they determined that AI-powered predictive maintenance provided value that simpler monitoring systems couldn't deliver. The volume and velocity of sensor data exceeded what human operators could possibly review, making AI an appropriate solution for this specific challenge. The third question assesses whether the problem requires continuous learning and adaptation. AI systems can continuously improve their performance as they encounter new data, adapting to changing conditions without explicit reprogramming. This capability proves particularly valuable in dynamic environments where conditions change frequently or unpredictably. If your business problem involves relatively stable conditions and predictable variables, simpler approaches that don't require continuous adaptation often provide more reliable results. An e-commerce company applied this question to their product recommendation system. Customer preferences constantly evolved based on seasonality, trends, and changing inventory. A recommendation system that couldn't adapt to these changes would quickly become ineffective. They determined that a machine learning solution that continuously learned from customer behavior provided value that static recommendation rules couldn't match. The fourth question examines whether the potential value justifies the increased complexity. AI implementations typically require more resources, technical expertise, and ongoing maintenance than simpler solutions. This additional complexity creates both direct costs and potential risks, including system failures, unexpected behaviors, and challenging troubleshooting. The potential value must justify these increased costs and risks. A logistics company applied this question when evaluating solutions for route optimization. While an AI solution might improve optimization by 3 to 5% compared to their existing algorithm, they determined that this marginal improvement didn't justify the significantly increased complexity and cost. They instead focused their AI investments on areas where the potential value more clearly justified the additional complexity. When applied systematically, these four questions help organizations identify where AI can create genuine business value and where simpler approaches might deliver better overall results. This targeted approach to AI implementation ensures that organizations focus their investments on problems where AI's unique capabilities create substantial competitive advantage, rather than spreading resources across projects where AI adds limited value. As Andrew Ng points out, not every situation requires an AI agent. He emphasizes that the decision to implement AI depends on the complexity of the problem and the level of control one is willing to give up. Simple queries with high human involvement are often best suited for simpler solutions, while more complex problems needing higher autonomy may truly benefit from AI agents. George Westerman provides additional guidance for this evaluation, highlighting that the choice of the right technique depends on several factors, including the required accuracy, the cost of being wrong, the need for explainable answers, the need for consistent answers, and confidentiality requirements. These considerations help determine whether AI is the appropriate solution for a specific problem, ensuring that the chosen approach aligns with business needs and risk tolerance. Organizations that apply this evaluation process consistently report more successful technology implementations. Rather than pursuing AI as an end in itself, they focus on selecting the most appropriate technology for each specific business challenge. This targeted approach leads to faster implementation, lower costs, and more reliable results across their technology portfolio. The payoff of this evaluation process comes through more strategic resource allocation. Organizations avoid wasting resources on overly complex solutions for problems that don't require AI's unique capabilities. Instead, they focus their AI investments on problems where pattern recognition at scale creates unique value, areas where AI delivers capabilities that simpler technologies cannot match. This focus on appropriate technology selection rather than blanket AI implementation represents a more mature approach to digital transformation. It recognizes that different business challenges require different technical approaches, with AI representing one powerful tool in a broader technology toolkit rather than a universal solution for all problems. With a clear understanding of when AI actually creates unique value, we can now examine the specific business domains where AI consistently delivers transformative business impact. 4 key transformation zones have emerged as areas where AI applications consistently generate substantial returns on investment across industries and organizational types. And then the 4 transformation zones. Where exactly should you focus your AI efforts to generate the greatest business impact? While many organizations rush to implement AI across multiple fronts simultaneously, a more strategic approach identifies specific areas where AI consistently delivers substantial returns. MIT's George Westerman has identified 4 key transformation zones where AI creates the most significant business value across industries and organizations of all sizes. Understanding these transformation zones provides a practical framework for prioritizing AI investments. Rather than pursuing AI projects based primarily on technological interest or competitive pressure, organizations can focus their resources on areas that align with strategic priorities and offer the greatest potential return on investment. Many organizations make a critical error in their AI implementation journey by focusing on the wrong transformation zones first. They often begin with technically interesting but strategically peripheral applications or pursue projects based on ease of implementation rather than potential business impact. This misalignment between strategic priorities and AI investments leads to disappointing results despite successful technical implementation. A common pattern involves organizations implementing their first AI projects in areas with limited visibility or strategic importance. While these projects might succeed technically, they fail to generate enthusiasm among senior leaders or demonstrate AI's potential for transformative impact. This creates a challenging cycle where initial AI investments don't generate sufficient momentum to support broader implementation, limiting the organization's overall digital transformation. The first transformation zone focuses on creating emotionally engaging customer experiences through personalization and targeted interactions. This zone leverages AI to understand customer needs and preferences at an individual level, enabling organizations to tailor their offerings and communications to specific customer segments or even individual customers. The goal extends beyond basic personalization to creating emotional connections that drive loyalty and long-term relationships. AI applications in this zone include recommendation engines that suggest relevant products based on purchasing history and browsing behavior, dynamic pricing systems that optimize offers based on customer value and market conditions, and conversational interfaces that provide personalized support across communication channels. These applications transform the customer relationship from transactional interactions to ongoing conversations informed by comprehensive understanding of each customer's preferences and needs. What makes this transformation zone particularly powerful is that it directly addresses the growing customer expectation for personalized experiences. Modern consumers increasingly expect companies to understand their preferences and anticipate their needs across interaction channels. Organizations that leverage AI to deliver this level of personalization create significant competitive advantage in customer acquisition and retention. The second transformation zone focuses on improving operations through automation and optimization, what Westerman refers to as Industry 4.0. This zone applies AI to streamline processes, reduce costs, and improve efficiency across manufacturing, supply chain, maintenance, and back-office functions. The goal is creating operations that respond dynamically to changing conditions while maintaining quality and cost efficiency. Cisco, the food service delivery company, exemplifies successful implementation in this zone. They leverage AI across multiple operational areas, to optimize delivery routing, predict inventory needs, and automate warehouse operations. These applications don't simply automate existing processes. They fundamentally transform operations by enabling real-time adjustments based on demand patterns, supply constraints, and delivery conditions. This transformation zone often yields the most immediate and measurable financial returns. Operational improvements directly reduce costs and increase efficiency, creating tangible financial impact that resonates with senior leaders. The concrete results from these applications often build momentum for broader AI implementation, establishing credibility for more ambitious projects in other transformation zones. The third transformation zone involves innovating business models to create new value streams. This represents the most strategically significant but also most challenging transformation zone, as it fundamentally rethinks how organizations create and capture value. Rather than simply improving existing offerings, this zone leverages AI to develop entirely new products, services, and revenue models. In this zone, organizations transform physical products into service offerings, monetize data and insights previously generated as byproducts, and create platform businesses that facilitate transactions between third parties. These innovations move beyond operational efficiency to create entirely new sources of competitive advantage and revenue generation. What distinguishes this transformation zone is its focus on using AI to rethink fundamental business assumptions rather than simply improve existing processes. Organizations that successfully implement AI in this zone don't just perform better, they operate differently, often disrupting established industry structures and competitive dynamics. This creates potential for exponential rather than incremental value creation. The fourth transformation zone focuses on enhancing employee experience and productivity. This zone uses AI to augment human capabilities, streamline workflows, and improve employee satisfaction across functions and levels. The goal is creating work environments where technology handles routine tasks, while enabling employees to focus on higher value activities that leverage uniquely human capabilities. Denso Creative provides an instructive example in this zone. The advertising firm implemented AI tools that automate mundane aspects of creative production, enabling their creative professionals to focus on conceptual work and client relationships rather than repetitive tasks. This application doesn't simply improve efficiency, it transforms the nature of creative work itself, allowing professionals to spend more time on activities they find meaningful and valuable. This transformation zone creates value through improved productivity and enhanced employee retention. By eliminating frustrating routine tasks and enabling employees to focus on meaningful work, these applications increase both output quality and employee satisfaction. As Westerman notes, satisfied employees often create satisfied customers, creating a virtuous cycle that enhances overall business performance. While all four transformation zones offer significant potential value, operational improvement typically delivers the fastest ROI for most organizations. Applications in this zone address concrete business challenges with clearly measurable financial impact, making them ideal candidates for initial AI implementations. The tangible results from these applications often build organizational confidence and capabilities for more ambitious implementations in other zones. However, the greatest value typically emerges when organizations implement AI across multiple transformation zones in coordinated fashion. Customer experience innovations inform operational improvements, which enable business model innovations, which enhance employee experiences. These interconnections create synergistic effects that exceed the value of isolated implementations in any single zone. The most successful organizations view these transformation zones not as separate domains, but as interconnected facets of a comprehensive AI strategy. They prioritize implementations based on strategic priorities and organizational readiness while maintaining a long-term vision that encompasses all four zones. This integrated approach creates a multiplier effect where success in one zone accelerates progress in others. These four key areas, customer experience, operations, business models, and employee experience, provide a comprehensive framework for identifying where AI can drive business transformation. This framework helps organizations move beyond generic AI aspirations to specific applications that create tangible business value. By focusing investments on these proven transformation zones, organizations maximize the likelihood of generating substantial returns from their AI investments. As AI technologies continue to evolve, a new capability is emerging that has the potential to accelerate transformation across all 4 zones simultaneously. AI agents, systems that combine reasoning, planning, memory, and tool use capabilities, represent the next evolution in business automation. These systems extend beyond isolated applications to coordinate complex workflows across functional boundaries, creating new possibilities for transformation across all 4 zones. Let's examine how these agents are transforming from theoretical concept to practical business tools in 2025. AI agents, the next evolution. How are AI agents transforming from theoretical concept to practical business tools in 2025? While many business leaders now understand the basics of AI implementation, a significant evolution is occurring that promises to transform how organizations automate complex business processes. AI agents represent systems that combine reasoning, planning, memory, and tools to perform tasks autonomously, moving well beyond the capabilities of traditional AI applications. To understand AI agents, we must first clarify what makes them distinct from the AI systems most organizations have implemented to date. Unlike traditional chatbots or basic generative AI applications that respond to specific prompts with single outputs, AI agents operate through iterative processes that more closely resemble human problem solving. They can assess their own performance, access external resources, plan multi-step approaches to complex problems, and even collaborate with other specialized agents to accomplish tasks. This distinction matters tremendously for business applications. While a traditional chatbot might generate a customer response based on a single interaction, an AI agent can manage an entire customer journey, retrieving account information, diagnosing problems, implementing solutions, documenting interactions, and escalating complex issues to human representatives when necessary. This ability to coordinate end-to-end processes rather than individual tasks creates entirely new possibilities for business automation. Andrew Ng, a leading AI researcher, has identified 4 major design patterns that form the building blocks of effective agentic workflows. These patterns provide a framework for understanding how AI agents accomplish complex tasks and offer guidance for organizations implementing agent-based systems. The first pattern, reflection, enables AI to improve its own outputs through self-assessment and iteration. Rather than generating a single response and considering the task complete, an agent with reflection capabilities reviews its own work, identifies potential improvements, and generates refined outputs. This process mirrors how humans revise written documents or refine solutions to complex problems. In practice, this reflection pattern transforms how AI systems generate business outputs. A marketing agent drafting campaign content doesn't simply produce a draft and stop. It assesses the draft against marketing objectives, identifies weaknesses in messaging or structure, and generates improved versions until it meets quality thresholds. This iterative refinement process significantly improves output quality compared to single-pass generation, making AI-generated content more useful for business applications. The second pattern, tool use, allows AI agents to interact with business systems through APIs and other integration mechanisms. Rather than being limited to generating text or images, agents with tool use capabilities can access customer databases, update CRM records, process transactions, and interact with operational systems. This capability transforms agents from passive responders to active participants in business processes. A financial services organization demonstrates this pattern through an agent that processes loan applications. The agent doesn't simply review application information. It accesses credit bureau data through APIs, applies underwriting rules stored in business systems, generates approval documents through document management systems, and initiates funding processes through transaction systems. This integration with business tools enables the agent to manage the entire process rather than isolated components. The third pattern, planning, enables AI agents to break complex tasks into logical sequences of actions. Rather than addressing only the immediate step, agents with planning capabilities develop comprehensive approaches to multi-stage problems, determining appropriate sequences and dependencies. This ability to plan transforms how agents approach complex business processes. A supply chain agent exemplifies this planning pattern. When tasked with resolving a product shortage, it doesn't simply place orders with the primary supplier. Instead, it develops a comprehensive plan, evaluating inventory across distribution centers, identifying alternative suppliers, calculating transportation times from different sources, assessing cost implications of expedited shipping, and determining optimal ordering quantities from each source. This planning capability enables the agent to develop optimal approaches to complex problems rather than implementing simplistic responses. The fourth pattern, multi-agent collaboration, involves specialized agents working together to accomplish tasks that exceed the capabilities of any single agent. Rather than using a general-purpose agent for all tasks, this pattern creates specialized agents with deep capabilities in specific domains, then coordinates their efforts to address complex problems. This specialization and collaboration mirror how human teams leverage diverse expertise to solve multifaceted challenges. A product development process demonstrates this collaboration pattern. A research agent specializes in analyzing market trends and competitive offerings. A design agent focuses on creating product concepts based on research insights. An engineering agent evaluates technical feasibility and production requirements. And a financial agent assesses cost implications and pricing strategies. A coordinator agent manages interactions between these specialized agents, ensuring information flows appropriately and reconciling conflicts when they arise. This collaborative approach enables handling complex processes that span multiple domains and require diverse expertise. By combining these four patterns, AI agents can automate increasingly complex business workflows in 2025. Organizations that effectively implement these patterns create agents capable of handling end-to-end business processes with limited human intervention. Rather than automating isolated tasks, these agents manage comprehensive workflows, adapting to changing conditions and coordinating activities across functional boundaries. A customer service example illustrates this combined approach. When a customer reports a complex product issue, an agent implements all four patterns simultaneously, using reflection to improve its understanding of the problem, accessing tools to review the customer's history and product documentation, planning a systematic troubleshooting approach, and collaborating with specialized agents for technical diagnostics, warranty assessment, and repair scheduling. This comprehensive automation transforms customer service operations by handling complex interactions that previously required extensive human involvement. What makes this development particularly significant is how it extends automation beyond structured, predictable processes to areas requiring judgment, creativity, and complex decision-making. Traditional automation excels at standardized, rule-based processes, but struggles with exceptions, ambiguity, and novel situations. AI agents handle precisely these challenging scenarios, dramatically expanding automation's potential scope. For business leaders, understanding these emerging agent capabilities creates new strategic possibilities. Processes previously considered too complex or judgment-intensive for automation now become viable candidates for AI-powered transformation. This expanded automation potential will allow organizations to rethink core business operations, potentially transforming cost structures, service models, and competitive positioning across industries. As we consider this potential, a critical question emerges for business leaders. How can organizations begin implementing these agent-based systems in practical, manageable ways? Rather than viewing agents as an all-or-nothing proposition requiring enterprise-wide transformation, successful organizations start with focused implementations that deliver measurable value while building organizational capabilities. Let's examine how businesses of all sizes can begin this implementation journey through practical, incremental approaches. Starting small, the practical path forward. What if you could achieve significant AI wins without massive investment or organizational overhaul? Many leaders believe implementing AI requires enterprise-wide digital transformation initiatives with substantial budgets and extensive restructuring. This perception creates a significant barrier to adoption, especially for mid-size organizations with limited resources. The reality proves much more encouraging. Organizations across industries have discovered that starting with small, focused AI implementations often delivers greater value. than ambitious, large-scale projects. Starting small means selecting specific business problems where AI can create measurable value without requiring extensive changes to existing systems and processes, rather than attempting to transform entire departments or functions simultaneously. This approach identifies discrete opportunities where targeted AI application can deliver clear improvements in efficiency, accuracy, or insight generation. George Westerman's research at MIT challenges the common belief that AI requires enterprise-wide transformation. His findings show companies achieving substantial value through smaller transformations with generative AI rather than attempting large-scale overhauls. These smaller transformations focus on individual productivity, specialized roles and tasks, and direct customer impact, allowing for more manageable and iterative approaches to AI adoption. This incremental approach contradicts the prevalent narrative about AI implementation promoted by many consulting firms and technology vendors. These organizations often emphasize comprehensive transformation programs that involve substantial technology investments, extensive process redesign, and organization-wide change management. While such approaches might eventually deliver value, they create significant implementation complexity, extend timelines, and increase project risks. To identify the right starting points for AI implementation, organizations need a systematic framework for evaluating potential projects. This framework assesses opportunities based on both business impact and implementation complexity, helping identify quick wins that deliver meaningful value with reasonable effort. The first evaluation dimension focuses on data availability and quality. AI systems require appropriate data to generate meaningful insights or automate decisions. Projects with readily available high-quality data typically present lower implementation barriers than those requiring extensive data collection or cleanup efforts. Evaluate whether the required data already exists in your systems, whether it's complete and accurate, and whether existing data policies allow its use for the intended purpose. Projects leveraging existing well-structured data typically provide faster implementation paths than those requiring new data collection infrastructure. A retail organization applied this principle when selecting their first AI implementation. Rather than attempting customer behavior prediction requiring integration across multiple systems, they focused on inventory optimization using their existing warehouse management data. This approach allowed them to deliver measurable value without first addressing complex data integration challenges. The second dimension assesses business impact potential. This evaluation considers both the financial impact and strategic importance of the problem being addressed. Financial impact includes both direct benefits like cost reduction or revenue increase and indirect benefits like improved decision quality or reduced risk. Strategic importance considers how closely the project aligns with organizational priorities and how visible its impact will be to key stakeholders. Projects with clear, measurable value generation and strong strategic alignment typically create greater organizational momentum for further AI adoption. A healthcare provider demonstrates this prioritization approach. While they identified numerous potential AI applications across clinical and administrative functions, they began with appointment scheduling optimization. This focused project delivered measurable financial impact by reducing no-shows and improving provider utilization while directly supporting their strategic goal of improving patient access to care. This combination of clear financial benefit and strategic alignment generated enthusiasm for additional AI projects. The third dimension examines implementation complexity, including technical requirements, integration needs, regulatory considerations, and organizational readiness. Technical complexity involves evaluating whether the project requires advanced AI capabilities or can leverage more established techniques. Integration complexity assesses how the AI solution must connect with existing systems. Regulatory considerations examine whether the project involves data or decisions subject to specific compliance requirements. Organizational readiness evaluates whether the affected teams possess the necessary skills and willingness to adopt new approaches. A financial services firm applied this complexity assessment when selecting their initial AI projects. While they identified potential applications in loan underwriting, they recognized the significant regulatory considerations and organizational change requirements involved. They instead focused first on marketing campaign optimization, an area with fewer regulatory constraints and greater organizational readiness for new approaches. This allowed them to develop AI implementation capabilities before tackling more complex applications. This systematic evaluation process helps identify opportunities in the sweet spot, high business impact with relatively low implementation complexity. These opportunities allow organizations to deliver meaningful value while building their AI implementation capabilities. As organizations complete these initial projects successfully, they develop both technical expertise and organizational confidence for more ambitious implementations. Small wins build organizational confidence through demonstrated results. When employees directly experience AI's benefits in specific, well-defined contexts, they develop more realistic expectations about its capabilities and limitations. This practical understanding helps counteract both excessive hype and unfounded fears about AI, creating a more balanced organizational perspective that supports appropriate adoption. These initial successes also build critical capabilities for more extensive implementations. Technical teams develop practical experience with data preparation, algorithm selection, and integration challenges. Business teams learn how to effectively collaborate with technical experts and incorporate AI outputs into their workflows. Leadership teams refine their approaches to project selection, risk management, and change implementation. These capabilities provide the foundation for more ambitious AI initiatives as the organization matures. You can start small with AI and still see significant efficiency gains by focusing on well-defined problems with clean data. The key lies in selecting problems where pattern recognition at scale creates clear value and where existing data assets support effective implementation. Rather than attempting to transform everything at once, identify specific processes where AI can deliver measurable improvements without requiring extensive system changes or organizational restructuring. For example, an insurance company began their AI journey by applying document processing automation to policy renewal forms. This focused application addressed a well-defined problem: the time-consuming manual review of standardized documents. Using existing data from their document management system, the project delivered a 70% reduction in processing time while requiring minimal changes to existing workflows. This success created momentum for additional AI projects addressing increasingly complex challenges. This incremental approach doesn't mean limiting your ambition. Rather, it involves sequencing your implementation to build capabilities and confidence systematically over time. Start with projects that deliver clear value with minimal complexity, then progressively address more ambitious opportunities as your organization develops implementation experience and technical expertise. While starting small delivers significant benefits, it also reveals important leadership challenges that must be addressed for successful AI implementation. Westerman emphasizes that the hard part of digital transformation is not the technology, it's changing the way the business works. As organizations move beyond initial AI projects to more comprehensive implementation, leadership approaches become increasingly important determinants of success. The leadership challenge extends beyond selecting the right projects to creating an organizational environment that supports effective AI adoption. This includes developing governance approaches appropriate to your organization's structure and culture, facilitating productive conversations about AI's role in your business, and creating a culture that balances innovation with appropriate risk management. Let's examine these leadership challenges and how they shape successful AI implementation. The leadership challenge. Why is successful AI implementation more about leadership than technology? MIT's George Westerman provides a compelling answer with what he calls Westerman's Law. Technology changes quickly, but organizations change much more slowly. This insight cuts to the heart of why so many AI initiatives fail to deliver expected value despite technically sound implementation. The technology itself rarely represents the primary barrier to success. Instead, the challenge lies in adapting organizational structures, processes, and cultures to leverage AI's capabilities effectively. This distinction matters tremendously because it fundamentally changes how organizations should approach AI adoption. When leaders view AI primarily as a technology challenge, they focus on selecting the right platforms, securing technical talent, and managing implementation logistics. While these elements matter, they represent just a fraction of what determines success. The more significant challenge involves reimagining how work gets done, redistributing decision-making authority, and helping employees develop new skills and mindsets. Consider the experience of organizations that have successfully implemented AI solutions. Their primary challenges rarely involve technical limitations or algorithmic performance. Instead, they struggled with prioritizing competing opportunities, managing risks across organizational boundaries, and building the capabilities needed for sustained adoption. These challenges reside squarely in the leadership domain rather than the technical realm, requiring different approaches and skills than traditional technology implementation. The first leadership challenge involves prioritizing what to do with AI. Unlike previous technologies with relatively clear application boundaries, AI presents almost limitless potential applications across every business function. This abundance of opportunities creates a prioritization challenge that can paralyze decision-making or lead to scattered efforts that deliver minimal impact. Leaders must develop frameworks for evaluating potential AI applications based on both business impact and implementation feasibility, allowing them to focus resources on opportunities with the greatest potential value. Société Générale, a French bank, demonstrated effective prioritization by soliciting 700 use cases from employees, then rigorously evaluating each based on potential impact and feasibility. Rather than pursuing all opportunities simultaneously, they implemented some cases immediately while delaying others until they established necessary infrastructure and expertise. This systematic approach allowed them to balance quick wins with strategic capability development, creating momentum while building toward more ambitious applications. The second leadership challenge involves managing risks associated with AI implementation. These risks extend well beyond traditional technology concerns to include ethical considerations, regulatory compliance, potential bias in automated decisions, and impacts on customer and employee trust. Leaders must develop governance approaches that balance innovation with appropriate risk management, allowing experimentation while establishing guardrails that prevent harmful outcomes. Different organizations adopt varying governance approaches based on their specific context, risk tolerance, and organizational structure. Some implement centralized governance models that provide strong oversight and consistency, but may slow innovation. Others adopt decentralized approaches that encourage rapid experimentation but increase the risk of inconsistent practices or compliance issues. Many successful organizations implement hybrid models that combine centralized standards with local flexibility, allowing controlled experimentation within established boundaries. Cisco, the food service delivery company, exemplifies a pragmatic approach to AI governance. They prioritize purchasing existing AI solutions over building custom applications, assess whether expert systems or statistical methods can address problems before considering more complex generative AI solutions, and maintain tight integration between business and technology teams throughout implementation. This approach reflects their specific risk profile and strategic priorities, demonstrating how governance should align with organizational context rather than following generic best practices. The third leadership challenge involves building the capabilities needed for effective AI implementation and ongoing operation. These capabilities extend beyond technical skills to include data literacy across the organization, cross-functional collaboration practices, experimental mindsets, and ethical awareness. Leaders must develop systematic approaches for cultivating these capabilities through training programs, hiring strategies, organizational structure adjustments, and cultural initiatives. Building these capabilities requires addressing legitimate employee concerns about AI's impact on their roles and futures. Many employees harbor anxieties about potential job displacement or devaluation of their skills as AI automates tasks they currently perform. Research by Daniel Rock indicates a significant percentage of jobs may see substantial portions of their tasks automated, creating legitimate concerns that leaders must address directly rather than dismissing. Productive conversations about AI's role require acknowledging these concerns while helping employees understand how AI can enhance rather than replace their contributions. Effective leaders emphasize how automation of routine tasks creates opportunities for employees to focus on higher value activities that leverage uniquely human capabilities like creativity, emotional intelligence, and ethical judgment. They provide concrete examples of how AI serves as a tool that augments human capabilities rather than a replacement for human involvement. Dentsu Creative provides an instructive example of this approach. The advertising firm began AI implementation by automating routine aspects of creative production, freeing professionals to focus on more strategic and creative work. Rather than imposing these changes from above, they encouraged employees to share ideas and best practices, creating a collaborative environment where AI became viewed as an enabler rather than a threat. This approach reduced resistance while accelerating adoption, demonstrating the value of involving employees directly in the transformation process. Creating a culture of experimentation represents another critical leadership challenge. Successful AI implementation requires willingness to test approaches, learn from failures, and continuously refine solutions based on real-world feedback. Leaders must create psychological safety that encourages appropriate risk-taking while establishing processes that capture and apply learnings from both successes and failures. This balance between encouraging experimentation and maintaining appropriate guardrails requires nuanced leadership approaches that many organizations struggle to implement effectively. These leadership challenges fundamentally transform the leader's role in technology implementation. Rather than primarily making technology decisions and overseeing implementation logistics, leaders increasingly serve as transformation facilitators who help their organizations adapt to new capabilities and ways of working. This shift requires different skills and approaches than traditional technology leadership, emphasizing change management, ethical reasoning, and organizational development alongside technical knowledge. By 2025, successful business leaders will have transitioned from technology decision makers to transformation facilitators who help their organizations leverage AI's potential. They will excel at identifying meaningful applications that create genuine business value, developing governance approaches that balance innovation with risk management, and building organizational capabilities that enable sustained adaptation to evolving technologies. Their primary focus will shift from implementing specific AI solutions to creating organizations capable of continuous learning and adaptation as AI capabilities continue to evolve. This transformation in leadership approach provides the foundation for sustained competitive advantage through AI. Organizations that simply implement specific AI solutions will achieve temporary gains that competitors can quickly match. Those that develop the organizational capabilities, governance structures, and cultural foundations for ongoing AI adaptation will create advantages that prove much harder to replicate. The leadership challenge thus represents not just an implementation hurdle, but the essential foundation for long-term value creation through AI. With this understanding of the leadership challenges involved in AI implementation, let's examine how these principles apply in practice through a case study of business transformation driven by effective AI adoption. Your aha moment. What will be your organization's AI aha moment? For Sarah Chen, CEO of a mid-size marketing agency, that moment came after months of frustration with her company's initial AI implementation. Her experience offers valuable insights for business leaders navigating similar challenges. When Sarah first decided to implement AI in her agency, she approached it primarily as a technology challenge. Like many leaders, she focused on selecting the most advanced tools and platforms, believing sophisticated technology would automatically deliver business value. She invested in a comprehensive AI platform designed to optimize campaign performance across channels, expecting it to transform their marketing operations almost immediately. The results proved disappointing. Despite significant investment, the system generated recommendations that often contradicted the team's experience with their clients. Campaign managers found the outputs either too obvious to be useful or too disconnected from client realities to be trustworthy. After 6 months of struggling to derive value from the system, utilization rates dropped to less than 20%. And Sarah began questioning whether AI offered genuine value for her business. The turning point came when Sarah attended a leadership workshop where she encountered Mokrian's three-legged stool framework. She realized her approach had fundamentally misunderstood what makes AI initiatives successful. We started with the platform leg of the stool, she explained, when we should have started with the problem definition and data strategy. We invested in sophisticated algorithms without first ensuring we had the right data foundation. This realization prompted Sarah to completely reset her approach. Rather than starting with technology, she gathered her leadership team to identify specific business problems where improved information processing could create substantial value. Through this process, they identified a persistent challenge. Their creative teams spent approximately 40% of their time on routine aspects of campaign development, creating content variations, writing basic ad copy, and generating initial design concepts. This problem definition provided the seat of the three-legged stool, a clear business challenge where automation could create measurable value by freeing creative professionals to focus on higher value activities. With this problem clearly defined, Sarah's team could evaluate the legs of the stool more systematically. They began by assessing their data readiness, the first and most critical leg. They discovered their campaign performance data resided in multiple systems with inconsistent formats and limited integration. Client briefs and creative assets were stored in a separate system with minimal connection to performance metrics. Before implementing any AI solution, they needed to create a unified data environment that connected campaign briefs, creative assets, and performance metrics. Rather than attempting to solve this challenge across the entire organization immediately, Sarah's team identified a specific client segment where they had the most complete data. They created a focused data integration project for these accounts, establishing a foundation they could build upon rather than attempting enterprise-wide transformation immediately. Only after addressing these data fundamentals did they evaluate algorithmic approaches and platforms, the second and third legs of the stool. Rather than selecting the most sophisticated option available, they chose solutions specifically designed for the creative workflow challenges they were addressing. These tools integrated with their existing systems and focused specifically on automating routine aspects of content creation and variation generation. This methodical, problem-focused approach delivered significant results within 3 months. Creative teams reported spending 30% less time on routine tasks, allowing them to focus on strategic client work. Campaign managers noted improved consistency across content variations, and client satisfaction scores increased for the accounts included in the initial implementation. What made this approach successful was its intentional focus on starting small with a well-defined problem and clean data. Rather than attempting organization-wide transformation, Sarah's team identified a specific function, content variation creation, where AI could deliver immediate value without requiring extensive process changes. This allowed them to demonstrate concrete benefits quickly, building organizational confidence for more ambitious applications. The success of this initial implementation created momentum for broader adoption. Team members who experienced direct benefits from the initial application became advocates for expanding AI use to other functions. The organization developed valuable implementation capabilities through this focused project, making subsequent initiatives more effective. Most importantly, the leadership team developed a more sophisticated understanding of when and how to apply AI effectively. As Sarah expanded AI implementation across her organization, she encountered the important distinction between AI workflows and AI agents, a distinction that transformed how she evaluated potential applications. She discovered that different business challenges require different approaches to automation, with important implications for implementation strategy. AI workflows excel at automating predictable sequential processes with clear rules and boundaries. These applications follow consistent patterns to deliver reliable outputs for standardized processes. Sarah's team successfully implemented workflow automation for campaign reporting, content approval processes, and media planning, areas with established procedures and relatively predictable inputs. AI agents, by contrast, handle adaptive challenges requiring judgment, contextual understanding, and the ability to adjust approaches based on changing conditions. These applications use reasoning, planning, and tool access to address more complex scenarios. Sarah's team began implementing agent-based approaches for creative concept development, client communication management, and market opportunity identification, areas requiring more sophisticated reasoning and adaptation. Understanding this distinction helped Sarah's team match appropriate approaches to specific business challenges. Rather than viewing AI as a monolithic solution, they developed a nuanced understanding of which problems required simple workflow automation and which benefited from more sophisticated agent capabilities. This matching process dramatically improved implementation success rates and reduced resource waste on overly complex solutions for straightforward problems. Dentsu Creative experienced a similar transformation in their approach to AI implementation. Rather than mandating AI adoption from the top down, they focused on helping their creative staff understand how AI could benefit them directly. As George Westerman notes, technology provides zero value to your company. What you do with the technology is what creates that value, how you change your business or your products to make it work better. Dentsu began by automating routine aspects of creative production, which freed their professionals to focus on more strategic and creative work. Crucially, they cultivated a collaborative environment where employees shared experiences and learned from each other, establishing office hours where people exchanged tips and best practices. This approach reduced resistance while accelerating adoption, demonstrating that successful implementation depends more on organizational culture than technical sophistication. The lessons from these experiences offer clear guidance for your organization's AI journey. First, start with the problem, not the technology. Understand the specific business challenge before determining the appropriate AI approach. Second, assess your data readiness honestly before investing in sophisticated algorithms or platforms. Third, begin with focused implementations that can deliver measurable value quickly rather than attempting enterprise-wide transformation immediately. Most importantly, recognize that technology itself creates no value. What you do with the technology determines its impact. Successful AI implementation isn't primarily a technical challenge, but a business transformation opportunity that requires thoughtful leadership, clear problem definition, and appropriate organizational adaptation. With these principles in mind, what specific business problem in your organization might benefit from AI enhancement? Where do you have clean, accessible data that could support effective implementation? And how might you start small while building toward more significant transformation? The answers to these questions will guide your path toward your organization's own AI aha moment. Throughout this exploration of AI's business potential, we've discovered that the real power lies not in technical complexity, but in practical application. Success depends on clearly defining specific business problems and establishing a solid data foundation before selecting algorithms or platforms. Your next step isn't hiring AI experts or purchasing expensive technology. Instead, evaluate your data strategy and identify a small, high-impact problem where AI can deliver measurable value. As George Westerman notes, technology changes quickly. Organizations change much more slowly. Remember this fundamental truth. Successful AI implementation isn't about technology transformation, it's about business transformation. The technology creates no value on its own. What matters is how you use it to solve real business challenges.